Hello everyone, this is section 7.4 from Big Ideas Math Geometry. So kind of a warm-up here that I thought would be fun to do is if we kind of look back at what we remember from parallelograms and triangles and use that to solve these two parallelograms. Well, I remember from parallelograms that opposite angles are congruent. So since this is 90, that means angle 3 has to be 90. And it really doesn't matter what order we solve these in. And I remember from a different chapter, since these are alternate interior, they're also equal. But now we have this triangle here. And we know that a triangle, all of its angles add to be 180. So we get that angle 1 is equal, angle 1 plus 90 plus 39 should equal 180. So angle 1 plus 129 should equal 180. I'll just subtract 129. We get that angle 1 is 51. Easy enough. All right, angle 4. Interesting. I don't know about angle 5 either. But I do know since these are alternate interiors, these should be equal. So that's going to give us 22 degrees. And now I can find angle 4 because this is a triangle right there. So angle 4 plus 22 plus 125 should equal 180. So that's angle 4 plus 147 minus 147. And we get that angle 4 is 33. Well, since this is 33, and these are alternate interiors, 5 should also be 33. And there we go. That's kind of the way we're going to solve some of these shapes that we're going to see today. And we've got 3 of them. So here are the 3 shapes we have: rectangles, rhombuses, and squares. So we're going to find out some properties about these. So a rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And a square has all 4 congruent sides and all 4 angles. Now, since these are parallelograms, don't forget, we also get that opposite sides are congruent and that opposite angles are congruent. And yes, that the diagonals bisect each other. Okay, so good stuff to know. Now, an easy way to remember this is by these corollaries. So, quadrilateral has 4 congruent sides, then it's a rhombus. If it has 4 right angles, it's a rectangle. And if it has 4 right angles and 4 congruent sides, it's a square. Here's sort of a Venn diagram of that. So all of those shapes, the rhombuses, the squares, the rectangles, they're all parallelograms. But then the rhombus is a special parallelogram with 4 congruent sides. The rectangle is a special parallelogram with 4 right angles. And the square has both of those. And as we talked about earlier, don't forget, parallelograms have 4 properties. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect. And same side angles add to 180. So all of these, the rhombus, the square, and the rectangle, also have these 4 properties. So as you can see, this is starting to be a lot of properties that we have to remember. So it's probably a good idea every time you see one of these shapes, you go ahead and mark the picture with the properties that we know. Okay, so classify this special quadrilateral. Well, easy enough. It's got 4 congruent sides, so it's got to be a rhombus. Now, Mr. Hunter, I thought squares had 4 congruent sides. They do, but also remember, all of their angles are 90. This is 70, so it is not a square. So it's a rhombus. 4 congruent sides. We don't know about all the angles, but we know it has 4 congruent sides, so it must be a rhombus. All right, so let's keep going. Some more things to know about rhombuses. Well, they've got this special property that their diagonals meet at a 90. So we actually end up with 4 90-degree angles right here. And the other important thing is that their opposite angles get bisected. So we know since these opposite angles are congruent, each of these is also congruent. So this one and this one and this one and this one, those are all congruent. This one, this one, this one, and this one are all congruent. So diagonals are perpendicular, so they make 4 90-degree angles. And also our diagonals bisect opposite angles. So we create 4 angles that are congruent on the opposites. Interesting. So let's look at this and let's see if we can use these rules to figure out the missing angles. So with a rhombus, we know that the diagonals make 90-degree angles here, and that also these angles are congruent to those angles, and these angles are congruent to these angles. So maybe we can put some numbers in and figure out what we have. Well, it looks like angle 1 is right here, but that mark means that it's 90. So cool. Angle 1 is 90. Well, this right here is 61, but that must mean this is 61, and this is 61, because all of those are congruent. So angle 2 is 61, and angle 3 is 61. But if you remember what we talked about earlier when we did our warm-up, all of these angles should add to be 180. Well, this is 61, and this is 90, and here's angle 4. So angle 4 plus 90 plus 61 should equal 180 because that's a triangle right there. Combine your like terms and subtract. And it looks like angle 4 is going to be 29 degrees. And there we go. We used our properties to solve this rhombus. All right, let's look at one more. And let's see if we can solve this one. All right, so we remember with rhombuses, I think maybe it's actually rhombi, I don't know. Your opposite angles are congruent. So this is congruent to this. And also, this and this is congruent to this and this. All right. Well, it's a bit of a thinker. How can we solve this? Well, I don't know. We're going to have to think about this. But I do know this from last section. Well, actually, the first section of this chapter. This is a quadrilateral, and the interior angles of a quadrilateral always equal 360. This is 118, which means this also has to be 118. But I don't know what any of these other four are. But they're all the same, so they can all be x. Well, how many x's do we have? 1, 2, 3, 4. So I have 4x plus 118 plus 118 has to equal 360. Might need a calculator for this one, so I'm going to go ahead and get my calculator ready. And I've got 118 plus 118, 236. So I've got 4x plus 236 equals 360. Well, if I subtract those two, I get 4x equals 124. Divide by 4, and we get that x is 31. So 1, 2, 3, and 4 are all the same, so they're all 31. 31, 31, 31, and 31. That was pretty fun. I enjoyed doing that one. It made me think a little bit. All right, so let's keep going. Well, the next thing we learn is that rectangles have congruent diagonal halves. So when we get these diagonals, they're all the same. Interesting. Okay, so it says in this rectangle, QS, this side, is 5x minus 31, and RT is 2x plus 1. But we know since this is a rectangle, those should be equal. DCM, SADMF. Add 31. We get 3x is 42. Divide by 3, and we get that x is 14. Now, it wants to know what each length is. So it doesn't say find x, it says find the length. So now I've got to go over here and go 5 times x, which is 14, minus 31. So 5 times 14 is 70, minus 31 is 39. So this whole length, QS, is 39. But if I wanted to find the halves, well, half means to divide by 2. So half of that is 19.5. But we know all of these are equal, so they're all 19.5. Okay. So that's kind of where we should stop for the day. We'll take some time soon to go over more of these properties in depth and maybe look at some squares. So this is 7.4 part 1. I hope you enjoyed.